Hello, Knights. Welcome. We are right back at it with these notes here and our videos. We are still continuing algebra, but this is a different unit. It's a little bit different. Before was algebraic expressions. Now we are starting our algebraic equations, just like it says here, equations. So we're going to be focusing more on how do we use equations in algebra and what we can do with them. So our first lesson is about solving one-step equations using addition and subtraction. If you don't know what a one-step equation is, that's fine. We are going to learn all about that in one of the key points. But we're just going to jump in by doing a little bit of an explore with a balance, which some of us saw in class today. So we have a little picture here. This is a balance where basically they are perfectly even. They weigh the same amount, and we can tell because it's a little triangle here that keeps it balanced. We need to figure out how much this one little cup weighs whenever on this side we have a different number of chips as on this side. So like it says here, each representation shows a balance. Determine what will balance one cup in each. You can take off squares or put new ones on as long as the balance is kept. So what that means is basically I can take squares off as long as I take one from each side. So if I look over here, I take one of these away from the cup side. If I didn't take one off from the other side, all of a sudden my balance, which would, it's like this right now, would suddenly go like this because this side got lighter. So since I took one from this side, I have to make sure I take one from the other side. Now I'm still not quite done because there's still several squares on this side. So I need to take another one away from here and one from here. I have two more, so I'm going to take two more away. So now I can see that the one cup was actually the same weight as 8 squares. So what strategy did we use to solve this problem? Well, we basically took from this side 4 chips, and from this side we took 4 chips. So what strategy? I removed 4 squares from both sides. Man, this is real sloppy. Let me rewrite this nice and neat. I remove 4 squares from both sides. Until the cup was alone. He's all by himself now. He's lonely. All right, so the next question, what will balance one cup? Well, whenever we took the 4 chips from both sides, we saw that 1 cup was worth 8 squares. So 1 cup was 8 squares. All right, our next one is pretty similar. There are a couple of squares on this side, a couple over here, and another cup. We need to figure out how much is this 1 cup worth. So I'm going to do the same process. Take one from here, 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 take one from here. And I can see that I have how many left? 1, 2, 3, 4, 5. So what strategy am I using? Same thing. I remove 3 from both sides. To make sure I keep it balanced. And what will balance 1 cup? Well, 1 cup was equal to 5 squares. Now we're going to describe the general strategy we use to keep the balance in questions 1 and 2. So that just means like, I want to make a general rule. What did I do to figure out the amount for each cup? Well, basically each time I removed this from both sides, the squares from both sides. I'm going to write this nice and neat. Let me go back and fix this a little bit. I removed the squares from both sides until the cup was isolated. And if you're like, isolated, what does that mean? Isolated is just like a fancy word that means alone. We use that because it's a math term, but basically it just means the cup is all by himself. He's alone, he's lonely. So each time we are removing chips, we make sure we take one from both sides. and we remove them until the cup is alone or isolated. All right, let's go ahead and look over to the next page. Key point number 1 says, to maintain the balance on the scale, I have to make sure I do the same operations to both sides. So there's a CFU, check for understanding. I want you to balance the scale below and then tell me how much 1 cup is worth whenever you balance it. So take about 1 minute, figure it out. How much was that 1 cup worth? And whenever you're ready to check your answer, resume the video. All right, so just like before, we're going to remove 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And in total, I can see how many of these do I have left? 1, 2, 3, 4, 5, 6, 7. So 1 cup was equal to 7 squares. Now, key point number 2, we have a couple of vocabulary words here. An equation that uses only one operation is called a one-step equation. So why is it called a one-step equation? Because it uses one operation. That means it's either add, subtract, multiply, or divide. And it only uses one of those. If it uses more than one, it's more than one step. So if it uses adding and subtracting, that's 2 operations, it's 2 steps. This is one-step equation, so we only do 1 step in 6th grade. In 7th grade, you get a little bit more challenging, and that's when you do more than 1 step. But we are going to just focus on 1-step equations in 6th grade. So I'm going to go back, and up here where it has my scale, I actually want to write what the equation is. So equation, what is the equation for this balance? Well, on this side, I have 5 and a cup. I'm going to call the cup the variable x. So on that side, I have 5, right? 5, and this guy's an x. On the other side here, before I cross them all out, I had 12. So 5 plus x equals 12 is my equation. Now the next key point number 3, a solution to an equation is any value that makes the equation true. So in this case, there's only one number that can work for x that makes this true. And we actually solve for it right here. Whenever we removed 5 from both sides, what was it that we ended up with? We ended up with x equals 7, because that's the only thing that you can add to 5 that makes 12. So this is called a solution, aka an answer. So solutions basically just mean the answer is what makes it work. Now key point number 4, inverse operations are pairs of operations that undo each other. So here you may have noticed we have 5x, sorry, not 5x, we have 5 plus x equals 12. To solve this, we had to get rid of the plus 5. How do we get rid of the plus 5? Well, we took these 5 things and we took them away. So we did minus 5. But to maintain balance, we also removed 5 from this side. So here, the plus 5 and the minus 5 went away. We were left with x is equal to 12 minus 5 is 7. So here, because I did addition and subtraction, those are called inverse operations. They undo each other. So addition undoes subtraction. It's the opposite. If I am trying to get rid of subtraction, then I have to add. But if I have subtraction, the opposite of subtraction is addition. So subtraction undoes addition. All right, we're not talking about these today, but I do just want to mention them. Multiplying and dividing. Obviously, if you want to undo division, you need to multiply. And if you want to undo division, you have to, wait, did I just say that? If you want to undo division, you have to multiply. If you want to undo multiplication, you have to divide. They're opposites, they undo each other. All right, we have a practice problem here. Notice there is a visual that's like a picture. And this is a big old blank scale. We're going to make a picture on the scale, whoops, based on our equation that they give us. And then we're going to write a verbal strategy, so like using words. Let's start out with our equation. We can see here that on one side, I have 12. So on this side here, I'm going to draw 12 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you need to actually draw all 12 of those blocks. We won't have to do this for every strategy, but just for today, we're drawing the picture. Then notice on the other side, I have x plus 4. I'm going to pretend like x is my cup, but instead of a cup, I'm going to be kind of lame, and I'm going to draw a big rectangle, label that with an x. And then I have 4. 1, 2, 3, 4. So down here in my description, on one side I have 12. 12 is the same as x plus 4. Now, how would I solve this using the model? Just like before, I would take one chip away from both sides until the cup is all by itself, or the x is all by itself. So my verbal strategy, remove 4 from not just one side, but both sides. So I remove 4 from both sides. Now, over here, I need to write what my solution actually is. Whenever we remove all of them, all 4, we have 8 left. So we know that x is equal to 8. But there's another way that we can show this. Here, I have plus 4. What is the opposite of adding? Yes, subtraction. So I need to subtract 4 from here. And if I subtract 4 from one side, I make sure I do it to the other. These two cancel out because they undo each other, and I'm left with x. Whoa, what in the world? I think my hand touched it. X is equal to 12 minus 4, which equals 8. Okay, we're going to do one more together, and then you're going to do those last two. So, next one, we have the same thing, another balance over here, and then over here we have another equation. My equation is x plus 3, so I'm going to draw an x plus 3 little squares, 1, 2, 3. And then I see that it equals 8, so I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8. And down here, I'm going to write x plus 3 is the same as 8. They are equal to each other because they are balanced. My strategy here, I'm going to remove 1, 2, 3, 1, 2, 3 from both sides. So my strategy, remove 3 from both sides. And here, I'm going to solve. How do I undo adding 3? What's the opposite of adding? The opposite of adding is subtracting. So minus 3 here. These two undo each other, so they go away, and I'm left with 8 minus 3. If x is 8 minus 3, that means x is equal to 5, and I can double check. There are 5 squares over here, so my answer I know is correct. All right, so there are 2 more questions that have the scales. So this one here, hold up. Yep, so you have 2 more. This one and this one, where it's talking about x plus 5 is 15 and 20 equals n plus 7. You need to complete this entire chart on your own for the rest of these notes. This video is a little bit shorter than normal, so these 2 parts of the table must be completely filled when you come back from your home this evening. This part down here, you're not going to worry about yet, not yet, because we're going to do it in class. So don't worry about these 2. You can leave them here. All you're doing for the rest of your assignment is these 2 problems here. If you come back without them completed, it will be assumed that you did not watch the video, and there will be a demerit for not completing your homework, so make sure you do it. All right, hopefully you guys have a good evening, and we will see y'all tomorrow.